Agora, just now the film, but before Mr. Dr. Chekhashov. Exactly.
Yeah, thank you very much, Mr. Chairman. And it's a great pleasure to make a presentation after my European colleagues and my friends. And it's my presentation will be devoted to our experience to work in Atlantic mostly. And it will be not only about massive sulfides, but mostly about massive sulfides. But I will try to make a short overview about another type of mineral deposits, I mean nodules and crusts in Atlantic. Yeah, this is our slide. You see that Eve already showed you the global distribution of sea floor massive sulfides in the ocean, and you see here there is two main provinces of or geological situation for the sea floor massive sulfides. This is mid-ocean ridges in all oceans, and this is so-called back arc basins. And these two systems differ only tectonically and volcanically, but for both situations, it is a true necessary condition for the formation of hydrothermal mineralization. These conditions are magmatic chamber, the source of the heat, and the tectonics. So this combination of these two parameters makes possible to start this, to drive the circulation of the seawater inside, and as a result to form such a beautiful and huge amount of massive sulfide or sports which we are dealing with. So the Russia historically started to work also in Pacific as well as it was started in East Pacific rise in the beginning of 80s and in the end of 80s, and started to work in the Kuril Islands. But then we moved to Atlantic. It was 20 years ago approximately. And 20 years ago we started to work here, and beginning from this, every year we have an expedition. And as a result, the results of these studies I will try to show you. Well, okay. So I will concentrate here on this part of this segment of mid-Atlantic ridge. Okay, now better. What's new discoveries? I will concentrate only on the recent last discoveries and at the mid-Atlantic ridge. So you see that during last 5 years there were discovered at least 5 new large seafloor massive sulfides. And the first one, this is chronologically, was discovered at 13 degrees and named Ashadze, after our main geologist. The second one was discovered 1 year later and named after another geologist, Russian Krasnov. The third one was discovered last year, and the last one was discovered this year and was named after the Russian football team, Denis. Yes, because it was the day when Denis won the Bavarian team and got a European Cup. And all the people on board, they made decision that they should be in the record on the map. Such a great event in Russian football history. Yeah.
Next time Brazil.
Next time Brazil. Well, now you see here these four huge deposits, and I will later make detailed information for all of them. But before it, I would like to show you the table with the classification of the massive sulfide deposits on Mid-Atlantic Ridge. And you see here that this line is important for us. You see there are two types of hydrothermal deposits in Atlantic. The first type is connected or related to basalts. So the hosted rocks are basalts. And another type is, this is a new type of deposits which was discovered in Logachov field in 1984. It was ultra-basic hosted. And for this moment, particularly this type of deposits is most interesting from geological and economical point of view, because the grades of the metals here are extremely high, and they are comparable with the grades of the deposits which we have in Papua New Guinea, which Nautilus are planning to start to product to exploitation in 2010 already. So this type of deposits are very important, and I'm sure that such type of deposits we will find in the southern part of Mid-Atlantic Ridge, and Brazilian geologists will get very important new discoveries. Well, now about geological setting and morphology of deposits which we have discovered last years. The first one is Ashadze. It was discovered, as I told already, 2003, and then extended later, and the last expedition was together with our French colleagues on board of a research vessel with a very French name, Pourquoi Pas. Yes, and it was very effective and give us a very interesting result. What are the features of this hydrothermal field? First of all, the Ashadze is the deepest for this moment. This is more than 4,000 meter water depth. And there is a specific animal community around this active mount. Then second feature is that it is related to ultramafic rocks, as I told you before. This is peridotite and gabbro. It consists of at least 4 sites, so this is a cluster of deposits. It's not one chimney or one mount, this is a cluster. And part of these sites are active and part are inactive. And I stress these inactive sites because from future, when we will talk about the production, we will start, of course, from inactive sites, because from environmental point of view, it's more logical and more comfortable for these animals who are living around these deposits. Well, so what is Ashadze is? This is the map, and you see that it is situated not on the Rift Valley. This is Rift Valley, and this is a slope, but on the slope, and this is approximately 8 kilometers between each of this side, and everywhere we have a different type of morphology of deposits. For example, if you'll go, first of all, about tectonic control. We mapped based on bathymetry, and we made a morphological map, and we recognized some tectonic dislocations. And we see that there is a structural control of the location of all of the sites which we discovered. And here you see the cross-section across the Rift Valley, and here we have Ashadze 1, Ashadze 2, and Ashadze 4. And this is the numbers of the age of deposits. I will go for this information later. Well, now Ashadze 1. So this is high-resolution map, approximately, this is 25 meters you see here, and this is how the field looks at the topography. So this is very rough topography, and here we discovered at least 4 or 5 active sites which are controlled by fault. It's evidently. Yes, such a photo we got from ROV, and you see here some of the chimneys already oxidized, and they are yellow by color, and the black one are the very fresh sulfides. And there are some animals here, actinia and others. And the actinias is the most popular and typical for this site animal. And some other slides and active smoker. We will show later the video, and you will see it in the movement. Yeah. As for the Ashadze 2, this is very interesting site, and Eve already showed you this map, and you see here that it is also very strict tectonic control. All of these mounts are hydrothermal, so they are sulfides, massive sulfides, and they are located along this line, which is tectonically by origin. And another structure which is extremely interesting, this is this crater, which is approximately 15 meters in diameter, but it is totally consists of massive sulfides. And the origin of this structure is still enigmatic. So we are still thinking how it could be formed. Was it explosion or was it dissolution? It is the subject for discussion. Well, the next one, very big one, named Semyonov, it was discovered last year. It has a very unusual geological setting because it's connected with the seamount, which is oriented orthogonally to the Mid-Atlantic ridge. It is also connected with partly with ultramafic and partly with basalt. It's inactive, very important. It is very large, very large. You see here, we estimated the resources, of course this is potential resources, as 13.7 million tons. And also consists of 4 sites as a cluster of deposits. And I should stress that we detected extremely high gold concentration in these sulfides, which is rather important. And this is a slide with the geological position of these Semyonov deposits. It is here on the slope, not in the Rift Valley. This is very typical for ultramafic faulted deposits. They are located not in the Rift Valley, but on the on the rift slopes. Yes, and this is a scheme. And I will show you this some results of the chemical analysis of the sulfides from northwest side. And look here, the average concentration of gold is 61.8 ppm gram per ton. We checked it twice. And you see here, we found such a concentration of this noble metal, and for sure we tried to make detailed mineralogical studies, and we found the native gold particles.
Please put the microphone.
Okay, sorry. Mm-hmm. And the next site is Logachev. It's very popular now, and it was visited many times by many international expeditions, but it was discovered in '94 from Professor Logachev research vessel. It is also consists of 4 or maybe 5 separate sites. 2 of them are active and another maybe inactive. And it has a very complicated composition. And secondary copper sulfides, especially enriched by gold again. So this is the geological position of Logachev. You see again that it is not in the Rift Valley, but on the top of the Rift slope, Rift mountain already. And here different geological maps for this. And this is a cross section. You see here that there is a control of deep fault zone, and it is situated on the. It is located on the steppe, and there is a strict tectonic control again for Logachev 1 and for Logachev 2. And this is a map which was produced by ROV Victor, and here you will find the real mounts, sulfide mounts. All of them, there are 11. They are detected as a massive sulfide deposits itself. And you see here again that there is a very strict tectonic control. All of them, they are located along the line, which are tectonically controlled. Yes. So some images of these beautiful black smokers. They named after some ladies from the expedition, Anna Louise, Irina, so the French and Russian girls, yes. So sometimes the chimneys are active, and you see here a lot of animals around. Sometimes they are inactive. For example, Quest Mount is inactive and no life around. And Logachev 2 is very interesting because of very high grade of gold again, and some dead clams, and with the sulfides and new portions of lava. And again, at Logachev was discovered the same structure as a smoking crater. So Krasnov deposits. This is very interesting from the point of view of their position first, and their size or dimensions second. It is situated on the conjunction between the volcanic high, neovolcanic high in the Rift Valley and Rift Mountains. And we mapped there two very big mounts or ore bodies, and the size of them is approximately 500 meters here. So if I already showed you the maps which were produced during Serpentine expedition, and this is the once again, this is the ore body itself, and you see here the outcrop of massive sulfides which we detected by profiling. It was 100 meter high. So this is a huge ore body or massive sulfides. And such image we got from ROV. You see here, this is a real massive sulfide, sometimes with a secondary copper minerals. It is on the stage of alteration. It showed such an alteration processes. And two last discovered sites which we visited this year. This is first one is Puy de Fol. This is French one because it was discovered earlier in. First is Zenith. Okay, I will start from Zenith. It was discovered this May, as I told you. It is still very bad studied, but we know only that it is very large. Here we have made a profiling, and we detected the massive sulfides along the 1 kilometer at least, in one direction, and half a kilometer at least in another direction. And the preliminary estimation is 11 million tons. And the first analytical data show us that this is mostly copper iron sulfides. It is inactive. We didn't detect any hydrothermal indication in the sea, near bottom waters. It is the geological map of this ore body. And the last one, this is Puy de Fol. It was discovered in '96 by French colleagues, but it was visited after 12 years by our ship, and we found there very interesting structures. They connected with the seamount, and it was very easy to study it because the surface of seamount is flat. This is like Galliot, where we study our crust. And here we found this new field, and it consists of at least 7 hydrothermal deposits. So our French colleagues detected 1, and now we have already 6 of them, and this is very good object for the future investigation. So now about the composition. Here you see the concentration of the main metals, the copper, zinc, gold, silver, cobalt, and nickel. And this is indication of the hosted rocks again. Ultra basic, basic, and questionable. And you see that the most interesting from the economical point of view is ultra basic hosted deposits. They have a very high concentration of copper, high concentration of zinc, high concentration of gold. And unfortunately, the big Krasnov field consisted mostly of iron sulfides, pyrite, marcasite, and but there is another small mound just near Krasnov, which has a copper zinc specialization. This is about the concentration. The same we see on the table, which show us the distribution of types of sulfide mineralization. The copper zinc, and copper iron types of mineralization related to ultra basic hosted deposits, Logachev and Ashadze, not for Krasnov and not for Semyonov. Here is the parameters. This is the same information which I told you before, but it is collected in one of the table. And here in the last column you see the resources which we estimated. And here at least four sites where the potential resources is higher than 10 million tons. You see here. If you will compare with the Star area, this is 4 million tons, and Salvaro 1 is 1.2, which are planning to explore, to start production in 2010 by Nautilus. Well, so we made some dating of the sulfides. I will not concentrate on this because of short of time, but I will show only that the oldest deposit is Krasnov. The oldest, the correlation is as older the deposit, as bigger. So this is very primitive, but we have such statistics. Yes, and also that the process of activization is not continued, but there is a gap when the activity, hydrothermal activity, was stopped. Yes, and this is show that this correlation between the age and size is very, very evident. Well, some methods. If already showed you the strategy to study the sulfides, I will show only some specific things which we use in our studies. So this is our old horse, Professor Logachev. We are working already 18 years on board on this. And we use for sampling different types of coring, dredging, box coring, and this is the list of the instruments which we use for sampling for the sediments, rocks, and sulfides itself. And one of our original technique is a marine geophysical system rift, which detected the electrical anomalies, and we use it for two aims. First, for recognition, to detect it, to locate it, the ore bodies itself, and the second, to estimate the thickness. For example, here this is a so-called blind deposits. We detected it by this system, and we didn't see it from the surface, but it was under the sediments. It's very effective methods to detect such a blind deposit. And ROV Victor was also very effective. And finally, some information about other types. This is crusts and fields of crusts and field of nodules which we found in our database near Brazil in the equatorial part. And we have some data which we are ready to contribute to the map which you compiled for this conference. There are some data for geochemical composition of this crust, and you see here, for example, that the cobalt is rather high and nickel not very. Sorry? Okay. Well, and finally, some devices which we use for the drilling of the crust. Working with this rig, we got the half a meter of the pores with the crust, which are very important to estimate the thickness and finally the resources of the cobalt-rich crust. Well, and summary remarks. So finally, during 5 years, the deposits at Mid-Atlantic Ridge became twice bigger. The average frequency for this moment is, if mentioned more than 50 kilometers, we estimate it as 100 kilometers, but this is pessimistic estimation. There is an evident structural control, which I mentioned. And there are different types of morphology of deposits. Many large inactive deposits, which is rather important, were discovered recently. There is a strong correlation between the age and size and resources finally of deposits. The grades of the most economically important metals are controlled by type of hosted rocks, degree of alteration, I didn't mention it, but it is really so, believe me, and the age of deposits. As for technological aspects, ROV systems are very important for detailed study. And electric and electromagnetic methods are also showed very good results. And last two conclusions. The first is that global potential of sea floor massive sulfides at the Mars is still underestimated. The future studies will lead to new discoveries, I am sure. All our last expeditions give us a new discovery. I am sure that we will continue to do it, and all geologists who will go to the south of Atlantic will do the same. And very important that international cooperation has no alternative. We should work together because the ocean is too big, and we will get together better results than alone. And finally, my acknowledgement for Polar Expedition for my French colleagues. Thank you very much. And now, as we agreed, for 5 minutes we'll show a short movie made in the Atlantic.
Okay, we have a short movie now.
Yeah.
Congratulations. The Institute for Geology and Mineral Resources of the Ocean, Russian Federation and the Institut Français de Recherche pour l'Exploitation de la Mer have a good cooperation. Congratulations. Football team and girls, it's important. Brazilian football team and girls also want cooperation too. Okay. Now the film.
Yes, the film. I will give the microphone to Ifuk.
But we can both command.
We can move.
They were the same crew. So this is deepest interval field in the ocean, HSD field, where you see here the clear smoke coming out at about 100 degrees. And this, say, low temperature fluid for us is precipitating mainly zinc sulfide. Zinc sulfide are forming, say, about 100 and 250 degrees. And you can see here anemones, shrimps. And so this is a cold part of the vents. Then when you move closer to the hot part, you see this black smoker, very active, and this is bringing at the seafloor fluids at temperature exceeding 350 degrees. And to transport and precipitate copper, for example, you need temperature higher than 300 degrees. So this smoker are directly precipitating the copper sulfide. And one point interesting and important is that to transport copper you need 300 degrees. That means that sea level, where we have a maximum of 100 degrees for boiling, you cannot transport and precipitate gold, copper. This means that you see interesting deposits in terms of zinc above 100 degrees, and copper you need to go deep.
So the animals around are very interesting. For example, these shrimps, they are blind, but they have such an organ as a heat radar. So they are looking for the warm water using this instrument inside of their body.
So I'm sorry, the movie on the screen is a little bit dark, but it's not always easy to get a good movie of black smoke on a black background. It should be lighter. But of course, black on black, when we are diving, you just see the black smoke from a few tenths of meter when you are diving. I remember diving with Nautil and passing, let's say, less than 50 meters from a very active black smoker, and I've not seen the black smoker. Here again, clear smoke. We measure the temperature here, and this was 98 degrees exactly. So 98 degrees, this is a good temperature for thermophilic bacteria, because we know that in those sites there are interesting bacteria that can live in really extreme environments, because here extreme is temperature of the fluid, extreme is the pressure, 4,000 meters, extreme is the concentration of metals. So we are really in those places where we can see the extreme of life on Earth. And here we have a series of tubes where here and there you can see that you have the living animals inside the tubes.
What the chemical composition of the smoke?
Yes. So the smoke, we say smoke, but it's not gas. It's just water mixed with water, because it's not boiling. We have no gas. But the water, in some bands, when you see the water coming out, you see that it's completely clear. And it starts to be black just a few millimeters, centimeters outside of the vent, where it starts to mix with the seawater. And when it starts to mix with the seawater, you start to precipitate the metals and the minerals. So the black smoke is copper sulfide, zinc sulfide, but also calcium sulfate. So it's a lot of tiny mineral particles. So here we change the zone, we move further north, 3,000 meters of water depth at the Logachev site, where in one spot, it's not like this everywhere, but in one spot we have really a high density of shrimps here. You can see them swimming in the hot water, but also at this place we have a lot of living mussels. So you see the shrimps.
only founding activities.
So some people, there's a general question when people look at this picture, they say, do you have tried to eat the shrimps? Do you have tried to eat the mussels? So some scientists have tried. I've not tried myself because me and probably Johnny, we know that in this environment there is a lot of copper, zinc, of course, and sometimes lead, sometimes arsenic, antimony, cadmium. So all these interesting metals you don't want to eat. But those people who have tried to eat, for example, the mussels, they were not sick the next day, but they have not tried another time. So here you see some fish, some small starfish.
It's very interesting that this concentration of life, a background for this, like a desert, so nothing life around. This is only few hundred of area which such a concentration of life.
So here some gastropods. So gastropods and the starfish are feeding on the dead mussels, and probably we forget to mention about life that this life is completely independent from the sun. The energy is not coming from outside, but the energy is coming from the earth. Say, it's for biology some kind of geological energy, because the starting point for this life is dissolved elements such as methane, hydrogen sulfide, hydrogen, and this the bacteria are feeding directly on this. So here you have a clear smoker where we have in this place boiling by separation, some gas coming out. Like you see, it stop and start to the normal way. So this means at this place we are close to the boiling point, about close to 400 degrees. And this is just for the end of this short movie. You see how we operate on the seafloor. Everything is slow. On the right, you have the main arm of Victor coming out, moving, ready for sampling. And on the left, we have another arm with legs flexibility, but you have two arms to operate. So now on the front, you have the basket with the first, on the base, we have two boxes with sterile water for the collecting bacteria. Then the instruments in the middle are titanium syringe to collect water, and the last group of instruments are short device for sampling and coring the sediment. Okay, that's all for the moment. Thank you.
São 12h17, nós vamos abrir agora para as questões. As questões abertas ao plenário, por favor, quem gostaria de se colocar? Kaiser? Ok. Depois dos outros, alguém na frente do Kaiser? Alguém?
Thank you very much.
Falou.
Thank you very much for your presentation. It was really very clear. Now we know much more about this matter. My question would be, in order to go to an unknown area and to make all of this research, how many days at sea and how much would it cost? I mean, I know it is a very difficult question, but I just would like to know how many years we are far from this kind of results, and how much money we need to go there. Thank you.
So it's a good question. So if we consider, we can compare with Northern Atlantic. The first active site on the Atlantic was found in '85. So, and you see how many deposits we have now. But there were really intense exploration south of the Azores through several 3 years program funded through the EEC. Then with the Russian group, the starting point was not hydrothermal activity, there was just to study the ridge and see where is the ridge. This was the point in the 70s or even in the 80s when we started to work in the Azore area in the early 90s. I remember I had some discussion before a cruise, just a few weeks before, to see where is the ridge. Should we go there or move 10 kilometers apart? Okay. So the first step is clearly to start the mapping. And you need time, 88, 85 to 20 years, 30 years. It's a very long-term program. To get at the point where we are on the Mid-Atlantic ridge, on the Northern Atlantic, but as Joachim has mentioned, we are still learning. Then in terms of cost, it depends. If you have a very small ship and if you are just dredging, okay, it's expensive, but it's not as expensive as, for example, the cruise we had last year, the French-Russian cruise on the Pourquoi, where we are using our biggest ship with all the equipment you have for sampling, mapping, and of course diving. But diving, you have different equipment for sampling, different equipment for this high-resolution mapping. Okay, but and also it depends the cost, because if you are, for example, as we are with the Russian group, when we are invited on the Russian ship, the French are not paying their ticket, and the same for the Russian scientists coming on our ship. So it depends whether you are on the scientific side or whether you are on the commercial side. And it's clear that if you are hiring a ship for oil research and drilling, it's really extremely high cost. But in terms of science, in France, Pourquoi, it's about 30,000 euro per day. But including the ship, the submersible, and this is not the commercial price. This is scientific price. But so I will not calculate right now a few numbers, but this gives you the idea. Several cruises a year, 30 days for a typical cruise, and okay, you have an idea. And all this is a lot of money. This is the reason why you have to make international cooperation, and what also we have to get funding. There is a big debate in France and also in Europe to see. Europe is funding some research, but it's never funding the ship time. And when you look at the real price for your research, central part for us and for the deep ocean is the ship time.
Okay, for the first part of question, the answer is that you should prepare the good maps. This is the necessary. You should have a good bathymetry in order to know where to go, because you can make the preliminary analysis, and there are some criteria, morpho-structural, where to go. This is for the preparation. As for the shift time, in Russia, the price approximately the same, 20,000 per day. But our expeditions is rather longer, 9 months, or because it's very long distance from Russia to Atlantic, and usually we are trying to make legs and then change the people every 1 hour and 1 month and a half.
Okay. Microphone, please.
I can speak loud.
Sorry?
Okay, will be a very cheap question after yours, okay? We dove in St. Petersburg is also an ultramafic route, and what I couldn't understand from there, why I wanted to clear, I don't know which of both I'm making the question, okay? We didn't see any bands, but we see some kind of alteration who could remind that was hydrothermal vent, and when we make a radioosmio analysis and plot against aluminum, it could have a clue that could be up from hydrothermal alteration. What I'm asking, what could we do to know, or what is a chance, or that we know, or it is a chance that could have a hydrothermal vent around the area? What can we do to know there is a vent there or was a vent there? Can you understand?
Yes, it's very simple.
Very simple.
Very simple, because we are looking for anomalies in the water and in the sediments around. So if we will find the anomalies, we can go to the source of this anomaly. The source of the anomalies are the deposits. So we are looking for once again, the indicators of hydrothermal activity or the deposit itself. This is some parameters, minerals, chemical, hydrophysical. That is why we are studying the water above the sea floor and the sediments around, and the rocks, of course. So this is rather simple.
Yeah, but I think, for example, I look at the data, we already have some multi-beam data, but very old with quite a narrow beam. So the resolution is
To
not
go
enough.
back there.
So the first, if you want to start something there, you have just to follow my line.
Just to follow your line and to go back.
You start to have a real new high resolution map from the surface, multi-beam map. At the same time, you can trace anomaly if they exist in the water column to look for the probe, and then collect sediments and do some near seafloor experiments to see if they are, just as Georgie said, trace the activity. But we know that I've seen recently that in some dredge in the sample area, they dredge some rocks with talc. And talc is typically a byproduct of the hydrothermal circulation in ultramafics. We know talc mineralization. It's not all deposits, but talc deposit around or even under the site in ultramafic environments. So it's the strategy is there. You need the ship.
So it's a good place to begin with, no?
Yeah.
Yes.
Okay. Two questions before Dr. Roberto Ventura. If you have a tectonic control, did you note enrichment in the intersection of faults Fultz and Roberto Ventura. Se você, eu acho que the intersection of fluids.
Yes, I understand.
Did you have note enrichment of sulfides? Okay.
Not in chemical sense, enrichment, but this is potential place for generation of the sulfides. About composition, this is another story. If you say enrichment, what did you mean when you say enrichment? Enrichment of chemical.
Yeah.
No,
enrichment.
No. Mostly this is a control of generation of deposit itself. This is tectonic control.
Hi, I have a brief question. Georgi, you present very interesting data on like very high gold numbers in the sulfide deposits, and my question is, you're working at almost 4,000 meters. So, how many samples do you have? I mean, what's which kind of control you have of the distribution of gold or, let's say, copper, zinc in this massive sulfide amount? I mean, do you have very good detail on the distribution of these elements, or you only have a few samples that means that you need to do more to understand the distribution, morphology, and things like that?
Of course, it depends on the stage where you are. If you make detailed works and you can make tens of stations, and we have a very good navigation on floor with transponders in order to have a very precise coordinates of each instrument which we use. And we are trying to make a net of the stations in order to estimate the zonality of composition of the ore body. But it takes time, and usually it is not the target for one cruise. Usually we do it during some cruises.
For instance, the Semyonov site, right?
Yeah.
You mentioned very high numbers, up to 69 ppm or gold.
Yeah, but
how many samples do you have in that?
We have only 10 samples for this moment. So all statistics based on these 10 samples.
One point to consider in terms of sampling is that sampling for the ship or sampling for submersible is just sampling the surface of the deposit. And to make a real estimate in terms of the quantity, you have to consider that most of these deposits are rapidly shown for the tag area. Most of the deposits have a zonation with the zinc at the surface, the copper-rich part deeper in the system. And for gold, for example, we know that in some places, particularly in the Pacific, the gold is in the low temperature deposit with the zinc, and in the Atlantic, in many places, the gold is with the copper-rich part of the deposit. So you really need to do science to understand these processes and to go further in the estimate in terms of mining or industrial interest. You need to precisely drill this site. So of course, when you are comparing different sites, and this is a point where we are when we are comparing the Atlantic, the Pacific, the Western Pacific. Some people publish a high value of this or this, but they just have 3 samples. Some others have big samples, but just a few samples, and they have 20 analyses on one sample. So if you want to compare one site to another, you have to consider the strategy you have for sampling, the strategy you have for analyzing, the equipment and the different techniques you are using for the analytical work. So you have to be very precise, and this is one of the reasons why it's not always easy to take in the literature the composition and say compare this and this. What we can do is think both of us, because we have quite a lot of experience and we have the same strategy of sampling and of analytical analysis of the samples for a long time, we can be quite confident when we are comparing our own data.
Yes.
Thank you very much for your excellent work and good presentation. I would say that it's very preliminary now, but very encouraging. It changed the situation of the Atlantic Ocean. I know that you have excellent scientific result. But the end of the game is the end part, the exploitability. When do you foresee a possible exploitation of these polymetallic nodules? Because you have good concentration of zinc, lead, gold, and silver, as the situation is now. I know that it's very recent result, even you are working on the subject now. And the second question is, in more concrete way, how do you see the international cooperation? I remember our friend Christian was talking about international cooperation. You also, the main solution will be international cooperation. At the end of the day, one should ask, what is, in a more concrete way, international cooperation? Thank you.
Okay, maybe I will start to answer. I hope that you understand that Yves and I, we are scientists. And the question when to start production, where, when, and who will do it, this is political decision. Yes, we just obtained the results. And we got some scientific information for our authorities, and we are waiting for results of the session of International Seabed Authority when the whole procedure will start. After this, we will make our decision, but not when I say we, it is not Yves and Georgi. This is we have some authorities above us who is responsible for all of these things. So unfortunately, I can't answer on your question. But we know that the experience of commercial companies is very effective and successful. And I mentioned that in 2010 already, Nautilus Minerals will start the production. They're planning to start the production of the massive sulfides near Papua New Guinea, and it is already in their plans. They have technique for recovery. They have a system for transportation, and they have a procedure for processing of the metallurgical processes of this. So they are ready to start, and this is a sign that this process will be global, and we are very near. We come very near to this moment when this production will start in the international water. But what time, when, I don't know.
So of course, this depends on politics, but also on economy, because when the prices are going very high, there is more interest. When they are going down, there is less interest. But you cannot think in our type of work in terms of short term. 1 2 years is not enough to prepare a cruise. You need several years. So this is economic and politics. For us in France at Ifremer, we are scientists, but we are scientists making the bridge between the scientific knowledge and the industry. We are just at the place where you do some kind of applied science. So this is politics and economy. Then the second part of your question was about cooperation. Of course, cooperation, I don't remember having been on one cruises where we had only French on board. So it's probably the same for most of our colleagues. We had cruises where we had 2, 3, 4 people from different countries. For example, in Europe, when working in the other area, we had people from Portugal, from France, from Belgium, from Ireland, from UK, all together in several cruises, sharing the data and so on. And Europe, but also other countries, and I had some discussion yesterday about this, about the word was about training of the young students from different countries. And Europe, for example, is having a specific program to get funding for young students from different countries even countries not having the ship or the capabilities to organize cruises, and for giving money for bringing these people, these young scientists on board to learn how to work at sea. So this is a positive, and I know that for the International Seabed Authority, you started last year, maybe you have some funding to get some students. So my feeling that on different sides of the world, this type of funding, of course you need funding, but it's less expensive than just funding the cruise. But I think this is a very interesting point for cooperation.
Sorry,
Final remark that the technological part is very important. Somebody has a very good instrument, another party has another good, and if you will combine them, this is more effective to work. This is very obvious and logical.
So it's a combination of this technology for the Russian side and the French side, complementary in terms of scales. I think we were both efficient to get results at different scale, and it's a good work, and we want to continue this work.
okay. Sorry, we have lunch now, but we have five questions more, and I think 10 minutes to 10 minutes. Quickly, please.
Thank you for an excellent presentation. My question is regarding the surveys on the inactive vent systems. We find, are you sure means how far effective it will be, the chemical and the physical anomalies in the inactive vent systems? We have, I worked for some time on this similar spreading ridges in the Indian Ocean, the slow spreading ridge, the Karsberg Ridge. We found that the central rift valley was sedimented. When we mapped it, there was nothing in that. When we dredged, we got nothing. But when we put a corer, we could get sediment from the rift valley. Then we went around the ridge systems, then volcanic mounts on the ridges. When we dredged, we got some sulfides. And I think the best method will be, especially in the inactive vent systems, it will be the electric and the electromagnetic and the magnetic anomalies, which will be more effective than the physical and the chemical. Because we don't find any anomalies as far as the temperature is concerned, because there are no active vents there. Then it's also possible that, we also worked on the inverted Y junction with the Germans sometime, and we had good mercury anomalies. We had anomalies, but when we dredged, we didn't get any.
I will ask my question in French for Dr. Fouquet. You will be better. Docteur, vous avez parlé, un peu prolongé la question de mon collègue du Sénégal, où vous avez parlé de coopération, mais en réalité, on n'a pas vu des gestes en faveur des pays africains. On sait que l'IFREMER a travaillé en Afrique longtemps, mais dans les travaux que vous avez présentés, on n'a pas vu des contributions de pays africains. Est-ce qu'encore une fois, dans ce grand projet d'intérêt humanitaire, les pays en développement, et les pays francophones notamment, sont laissés à la traîne et ne vont pas bénéficier de votre expertise? Vous avez choisi des partenaires russes, on peut le comprendre, mais ce que nous ne comprenons pas, c'est que dans cette coopération-là, il n'y a pas d'Africains, et ça, c'est... On voudrait que vous nous portiez des éclaircissements là-dessus, dans la mesure où il y a un certain nombre de travaux très pointus qui sont demandés dans le cadre de l'extension du plateau continental. Comment est-ce que les pays qui sont démunis pourront faire pour y arriver? Ça, c'était ma question. Merci.
Okay, write the questions, all the questions, then. Okay, you can answer. The next question.
Thank you. My name is Jin Jiantai from China. Yes, thank you for your excellent presentation. My question to Dr. Chirosawa.